Today we're going to look at some rational function graphs as an introduction to what these graphs look like. So I'm going to complete the maybe the first one with you and show you kind of how I want you to do the exploration, and then you can enter the other ones in your calculator and fill them in on this sheet. So graph each function. I wrote, make sure to put parentheses around the numerator and denominator. So for you to plug this in correctly in your y equals menu, make sure that you put a parentheses around the numerator and a parentheses around the denominator. So you're going to go to, if you don't have a graphing calculator, you should be using the one that was at the top of Google Classroom. It's still there. You can install it for free on your Chromebook, so please do that. Or you could use the Desmos app or a graphing app on your phone. So I'm going to go to the y equals menu, clear out what's in there. If any of these plots up top are highlighted like that, you do not want them to be highlighted because we're not doing a scatter plot. You arrow up, hit enter, make sure they're all currently off. So I'm going to type parentheses x plus 3 divided by parentheses x. Always make sure you're using this key as your minus key, minus 4, close parentheses. The first time you'll want to hit the zoom key and choice 6 for standard zoom, but every time afterwards you can just type graph and then you'll get that 10 by 10 viewing window. So the things that I want you to look at for are x-intercepts and y-intercepts. So I see that there's an x-intercept around this point, and we actually know what the x-intercept is because we've done a little work on rational functions. I know that it's at -3. But if you can't quite figure out what it is, just take your best guess. But -3, 0 is the x-intercept. Now I know that my y-intercept is somewhere down here on the y-axis. Some of you who've done work with the rational functions already, you know how to find the y-intercept. Plug in 0 for x and you'll get -3/4. So 0, -3/4 is the y-intercept. And then a vertical asymptote. So there's some vertical asymptote happening here. Hey, that is at 4, right? Because 4 minus 4 gives you 0 in the denominator. So x equals 4. It says, are there any other asymptotes that you notice? I notice that there's something horizontally going on. So where is the power bigger? They're equal in power, and when I strip the coefficients, it's getting awfully close to y equals 1. If you can't figure out all the asymptotes, maybe just take your best guess. And your graph doesn't have to be beautiful, but you could plot those few things that you noticed on your graph. So here's my asymptote. Oops. Here's this guy up here. Right? Here's this guy here. Something like that, just to show about what it looks like. These are going to look slightly different than each other. Maybe let's do another one that doesn't look quite the same. I'm just going to pick number 8. So why don't you go to number 8? So now I'm going to type this function in. So I've got, clear that out, I've got x squared minus 2x plus 1 divided by 6x minus 3. I hit zoom 6. I didn't have to, but I did. All right, so what's going on here? So we've got this kind of curve coming in and then this curve coming in. And can I tell what my x-intercept is? It looks like it's at 1. And actually, if I factored my numerator, isn't that x minus 1 times x minus 1? So yes, my x-intercept is at 1. Can I tell the y-intercept? It looks like it's right here at a negative value. Wouldn't that value be -1/3 if I plug in 0? So it helps just kind of reinforce looking at the graph, finding those pieces of information. Vertical asymptotes. It looks like I've got something going on here. And if I set the denominator equal to 0, don't I get 3/6 or 1/2? And it does look like that vertical line is at 1/2. And then it says any other asymptotes you notice. So there is a slant asymptote going in this direction. I can't tell from the graph what the equation is. So if you want to try the division dividing x squared minus 2x plus 1 divided by 6x minus 3. You could try that division. And maybe I'll do it just to review division. So 6x minus 3. My first term is x squared. What would I have to multiply by 6x to get x squared? 1/6 x, right? Because then 1/6 times 6 would be the coefficient of 1. What's 1/6 times -3? This is not going to be a great division problem for you to do. Would that be -1/2? Yep, so you get -1/2 x. How many x's did I want? -2.5. Oh yeah, this was kind of a messy problem. So this would have to be -1.5. So we don't have to go really any further on the division, but you can see that it did have a slope of 1/6. That would be a little bit harder, I think, than I would have you do for division. But if we were going to draw this function, you know, it kind of looks like this, maybe not quite that steep, and it kind of looks like this. So just getting rough sketches of what some of these rational functions look like. So take another 10 minutes and go through 2, 3, 4 the same way, 5, 6, 7 the same way, and you're going to send me a picture that you completed 18A. And then the second thing that we're going to do today, I'll pause the video, make a second.